What if Earth is not the only place in the universe where life exists? Before we look for life out there, we have to understand why life survived here. Earth is constantly being hit by energy from the sun. Solar radiation, charged particles, and violent solar storms are always traveling through space toward our planet. But Earth has something that protects it. A magnetic field, this invisible shield that helps deflect dangerous particles away from the surface. Without it, our atmosphere could be stripped away over time, and the chemistry needed for life would be much harder to protect. Deep inside the atmosphere, sunlight and radiation interact with molecules, breaking chemical bonds, creating reactions and shaping the environment where life eventually appeared. So when scientists search for life beyond Earth, they are not just looking for a planet that is the right size. They are looking for a world with protection, chemistry, energy, and enough stability for life to possibly begin. Number 5, Proxima Centauri b, a rocky planet orbiting the closest star to our Sun. We do not know if it has life, and we do not know exactly what its surface looks like. But because it is close, and because it sits in the habitable zone, it is one of the most interesting planets in the search for life beyond Earth. Proxima Centauri b is located in the constellation Centaurus, about 4.2 light years away. That sounds close, but only in astronomy. With current technology, it is still far beyond anything humans could visit. But compared to the rest of the galaxy, it is basically next door. That is why this system matters. If we ever study an Earth-sized planet around another star in detail, Proxima Centauri b would be one of the first targets. Because it orbits so close to its star, the gravitational pull from Proxima Centauri could have a strong effect on the planet. On Earth, the moon helps create ocean tides, but on Proxima b, the star itself may play a much bigger role. Its gravity could stretch the planet slightly, pulling on its oceans and creating powerful tidal movement. Those tides could help move heat around the planet, especially if one side receives more sunlight than the other. They could also mix the oceans, moving chemicals and energy through the water. That matters because life does not just need water sitting still, it needs movement, chemistry, and energy. So if Proxima b has rocks, oceans, and strong tidal forces, it may not be a calm, Earth-like world. It could be rougher, stranger, and more extreme. But those same tides could help create the kind of active environment where life has a chance. Number 4 is close to home, Saturn's moon, Titan. At first, it just looks like another moon orbiting Saturn. But Titan is not a normal moon. It has a thick atmosphere, weather, clouds, and entire lakes on its surface. And that is what makes it one of the most interesting places in the search for life. This footage is based on data from Cassini, the spacecraft that studied Saturn and its moons for years. And what it revealed about Titan was strange. These dark regions are not water. They are lakes and seas made of liquid methane and ethane. On Earth, we have a water cycle. Water evaporates, forms clouds, falls as rain, and flows into rivers, lakes, and oceans. Titan has something similar, but instead of water, it uses methane. Methane can fall from the sky as rain, carve channels into the surface, and collect into lakes near the poles. That makes Titan one of the only worlds we know with stable liquid on its surface. But the surface is extremely cold, too cold for liquid water to stay on top. So if life exists there, it may not look anything like life on Earth. One possibility is that Titan has chemistry happening in its methane lakes. Another possibility is that deep below the surface, under the ice, Titan may have a hidden ocean of liquid water. That is what makes Titan so interesting. It has two completely different environments that scientists care about. On the surface, there are methane lakes with complex organic chemistry. And underground, there may be a water ocean where life could be more Earth-like. Titan is not the easiest place for life. It is cold, dark, and chemically very different from Earth, but it has atmosphere, liquids, organic molecules, and time. And sometimes those are the ingredients that make scientists stop and ask, what if life does not need to look like Earth life at all? Number 3, Mars. It's a cold, dry desert, but billions of years ago, Mars was a very different world, with rivers, lakes, and water flowing across its surface. Water carved enormous valleys through the landscape, flowed down from the mountains, and collected inside vast lakes and craters. Places like Jezero Crater once held a lake fed by an ancient river system, leaving behind layers of sediment over time. And with liquid water, energy, and the right chemistry, Mars may once have had the conditions needed for simple microbial life to develop and survive. But that world slowly disappeared. Mars began losing much of its atmosphere, temperatures dropped, and liquid water could no longer survive across most of the surface. Rivers dried up, lakes vanished, and over billions of years, Mars transformed into the frozen, dusty desert we see today. But Mars may have left evidence of its past behind. The Perseverance rover has collected rocks from ancient lake and river environments, where signs of microbial life could have been preserved for billions of years. And if we can study these samples closely enough, they could finally tell us whether life once existed on Mars. Number 2, Europa. Orbiting Jupiter is a small frozen moon that from the outside looks almost completely lifeless. Its surface is covered in ice, enormous cracks, and strange reddish lines stretching for thousands of kilometers. Temperatures here can fall far below minus 100 degrees, and Europa is constantly exposed to intense radiation from Jupiter. But despite how hostile it looks from the outside, Europa may actually contain one of the most promising environments for life anywhere in our solar system, because underneath all of this ice is something enormous. Beneath Europa's frozen crust is believed to be a vast global ocean of liquid salt water, and incredibly, this hidden ocean may contain more than twice as much water as all of Earth's oceans combined. Protected beneath kilometers of ice, that water may have remained liquid for billions of years. That is what makes Europa so interesting. On Earth, wherever we find liquid water, a source of energy, and the right chemistry, we almost always find life, even in places once thought completely uninhabitable. Europa may have all three. Its ocean could interact with the rocky interior below, potentially providing chemicals and energy that microscopic organisms could use to survive. We don't know if anything is actually living beneath that ice, but unlike Mars, where we're mostly searching for evidence of a world that was habitable billions of years ago, Europa's ocean exists today, and somewhere beneath this frozen surface, there may still be an environment where life could exist right now. That possibility puts Europa at number 2. And finally, number 1, Enceladus. This small frozen moon of Saturn might be one of the most promising places in our entire solar system to search for life. And the reason is incredible. Enceladus is constantly ejecting huge plumes of water, ice, and other material hundreds of kilometers out into space. Those plumes come from beneath the surface, where a global ocean of liquid water sits underneath a thick shell of ice. And this isn't just something scientists predict. These are real images taken by the Cassini spacecraft, showing enormous jets erupting from fractures near the moon's south pole. Cassini even flew directly through these plumes, allowing scientists to analyze material coming from inside Enceladus. And deep at the bottom of its ocean, things become even more interesting. Water is believed to interact with the moon's rocky core, producing heat, chemical reactions, and sources of energy. Similar environments exist around hydrothermal vents deep in Earth's oceans, where entire ecosystems can survive without any sunlight at all. Enceladus appears to have 3 of the most important ingredients we associate with habitability: liquid water, useful chemistry, and a source of energy. And unlike many other worlds, it's actually throwing samples of that hidden ocean directly into space for us to study. That is why Enceladus takes the number 1 spot. But maybe it's time we went bigger. Should I rank the 5 biggest black holes in the universe? Like and subscribe for more.